All right, AP Calculus, AB, trying to find the area of curves that intersect at more than 2 points. We're going to start off by using this formula that I hope that we're familiar with. And this just says if we're looking for the area bounded by two curves, that we can do that by evaluating the definite integral from A to B of the top curve minus the bottom curve. So I think this makes good sense, but if you just look at this for a second, if you look from here to here, let the white curve be this curve right here, this x cubed thing. From here to here, the white curve is on top of the yellow curve, isn't it? But as we go from this interval from here to here, the yellow curve is on the top and the white curve is at the bottom. So we're going to have to actually evaluate this thing twice. So let's take a look at this for a second. The first thing I want to figure out is when do these two curves and where do these two curves intersect? So all I'm going to do is set them equal to each other. So I'm going to say the first function is equal to the second function where? The way that I'm going to do this is I'm going to move everything to the left-hand side, and I think that we end up with 3x cubed. We have negative, we're going to add positive x squared to both sides. That will cancel that. Negative 10x minus 2 more x is negative 12x. So that's just simple algebra. Set that equal to 0. So hopefully that makes good sense. What I want to do now is this. I want to factor out everything that I possibly can. So I think we can factor out from here 3x, can't we? So I factor out 3x. Well, 3x times x squared minus 4 is equal to 0. Still doing just intermediate algebra here. Going to factor this out a little bit more. 3x times x minus 2 times x plus 2 is equal to 0. Going to use algebra to evaluate this and ask yourself, for what x value does this whole thing turn to 0? Well, the x values that I get is x is equal to 0, x is equal to positive 2, and x is equal to negative 2. Well, that kind of helps me because that tells me here that this value right here, its x value is negative 2. The x value here with this intersection, it was pretty obvious, is 0, and the x value here is 2. Now what I have to look at is what happens with our function in these places. So I'm going to do that. I'm going to say that the area is equal to the definite integral from negative 2 to 0, right? From negative 2 to 0 of, and this is the one where x cubed is at the top, so it's that 3x cubed minus x squared minus 10x, right? Minus the bottom function, which is negative x squared plus 2x, right? Plus, so that gets us, just take a look at where we are. That gets us from here to here. Now we need to find this area over here. And in that area, the parabola is actually on the top. The yellow parabola is on the top. So I'm going to take that from 0 to positive 2. From 0 to positive 2 of g of x. And g of x, of course, was that negative x squared plus 2x, right? Minus f of x in this case, which is 3x cubed minus x squared minus 10x, right? The whole thing, I should have dx's at the end of all this. dx, right? Here, dx. So here, now I'm just stuck. I have to clean up my algebra here. I'm going to clean up my algebra here. I'm just going to wade through this algebra a little bit. Negative 2 to 0 of 3x cubed minus x squared minus 10x. I'm going to distribute this, so plus x squared minus 2x. If you don't mind, the whole thing dx plus this thing, which is negative x squared plus 2x minus 3x cubed plus x squared plus 10x, right? Going to keep cleaning up my algebra here. And this, if you remember, this was from 0 to 2, wasn't it? And this thing cleans up a little bit. This one is going to give me negative 2 to 0 of 3x cubed minus 12x, right? We've seen that before, plus the definite integral from 0 to 2 of that other piece, which should give us negative 3x cubed, doesn't it? Plus 12, yeah, it does, plus 12x. And that should make some sense also, right? And I have to remember to leave my dx's in there. Okay? So far I think it's going pretty good. Now we have to integrate. You're definitely going to see a problem like this. If you see it on free response, it would be this drawn out. If not, it will be some portion of this. But just to continue to press this on, I would go ahead and integrate this. So when you integrate this, you'd get 3x to the 4th over 4, wouldn't you? Minus 12x squared over 2, right? As evaluated, we're going to need to use these evaluation signs, from negative 2 to 0, plus negative 3x to the 4th over 4, right? Plus 12x squared over 2, as evaluated from 0 to 2. Of course, this cleans up, and this goes to 6x squared, and this goes to 6x squared. But I'm not even going to mess with that, because if I was taking this exam, I probably wouldn't clean this up. Finally, I would go to my reader and I'd say, now I intend to use the fundamental theorem of calculus, and I intend to evaluate f of 0 minus f of negative 2 plus, I have to do fundamental theorem of calculus twice here, plus f of 2 minus f of 0. And I'm not going to do all this work with you. You can do this arithmetic, but my answer came out to be 24. I hope that's right. If not, let me know. Look, I hope this is really helpful. My whole point here is that if it intersects on more than one place, more than two places, you have to figure out, are the functions switching places? That is to say, here, this function is at the top here, on this interval from here to here, on this interval from here to here, for all x values from here to here, this function is on top, but on the interval, the x values from here to here, the yellow function is on top, so we have to take our definite integrals in pieces. All right? I hope this was helpful. If you haven't already subscribed, please subscribe. Your comments are welcome, and thanks for all the support, you guys. I really appreciate it.